So let's up it up a little further. Let's say we have -5 and -6, and right now we wanna add this decimal values to 2's complement. How do we do this? Now both numbers are negatives, therefore we have to get a positive value of 5 and the positive value of 6, take the 2's complement and then add the 2's complement numbers. We're going to get the positive value of 5, which is 0, 1, 0, 1. And we are going to take the 2's complement. Like we all know, we flip 0 switches to 1, 1 switches to 0, 0 switches to 1, and 1 switches to 0. And then we add 1, which is 1, 1, 0, 1. And then we're going to do, and that is -5, which is same as this. And now we're gonna get the positive value of 6, then take the 2's complements. So the positive value of 6 is 0, 1, 1, 0. But it's very important to make your top value and your bottom value have the same number of bits. So we have +5, which is 1, 0, 1, and we have +6, which is 1, 1, 0. Now they have the same number of bits, but if you add a 0 here, you have to add a 0 here, and if you add a 0 here, you have to add a 0 here. You can add as many zeros as you want, but I mean, it's just safe to add 1 0 whenever you're doing a conversion from a decimal value 5 to a binary value. So +6 is 0, 1, 1, 0 in binary numbers. So now you're going to convert to 2's complements, which means you just flip each bit and add 1 to the last bit. So you flip 0, 1, flip 1, 0, flip 1, 0, flip 0, 1, and then you add 1 to the last bit, and that is 0, 1, 1 plus 0, 1, 0, 1. So now we know that this is -6. So now we know that -5 in 2's complements is 1, 0, 1, 1, and we know that -6 in 2's complements is 1, 0, 1, 0. So right now I'm going to erase this because there is something that very important that I want you to know. Now we have 1, 0, 1, 1, which we knew previously was -5, and we have 1, 0, 1, 0, which we knew previously was -6. And now we're going to add it. So 1 plus 0 is 1, 1 plus 1, 0, you have a remainder of 1, and we have 1, and now we have 1 plus 1, which is 0, and we have a remainder right here of 1. We know -5 plus -6 is -11, and we know that this is a 4-bit number, and -11 is a 5-bit number. So +11 in just the normal like binary notation is 1, 0, 1, 1. But like I told you, it's just safe to put a 0 right here in front. So that makes it a 5-bit number. Because if you remember, 5 is just 1, 0, 1. But because we added a 0 down here in front, that made it a 4-bit number. And if you remember, I told you that the top part, if it's 5 bits, the bottom part also has to be 5 bits, and of course your result has to be 5 bits. So now if we have 4 bits at the top and 4 bits at the bottom, but we have a 5-bit result, that is an overflow because we have more than 5 numbers. Don't worry, there's an easy way out, and it works every time. So if you notice, you're going to see that we have 1 on 1, and here is 0. That is the first sign to know that is overflow. Basically, if your most significant bit, in this case, is 1 and 1, and the most significant bit of your result is 0, then we know it's an overflow because it has to be 1. Same thing goes if your most significant bit is 0 and your results most significant bit is 1. This is also an overflow. But if we had a 1 or 0, it can either be 1 or 0. It doesn't matter. Also, if it was 0 or 1 for your most significant bit, it can either be 1 or 0. It doesn't matter. The only problem is when you have the same values for your most significant bit and then a different value for your least significant bit. So that's a very good way to check overflow. Very, very good way. So if this was 1, because we have 1, 1, 1 for your most significant bit, this wouldn't be an overflow. But because this is 0, that is why we have an overflow. So this is a very, very important check. So every time, the last thing you should do when you add 2 complements number is check your most significant bit. Check your most significant bit, and if you have discrepancies just like this, any one of those 2, then you know that it's an overflow. So in this case, because your most significant bit is 1 plus 1, we have a 0 and a 1 outside, and because your 1 plus 1 is 0 for your most significant bit, we now can say that this is an overflow, and that is your final answer. Your final answer proves that this is an overflow.